there. In this lesson, we're going to be looking at factoring trinomials, but we're going to be taking some little shortcuts here. This is the second part of factoring trinomials, and really, we don't technically need this. We can factor trinomials the same way that we did in the previous lesson, where we factor by grouping, but this is really nice. We have a really nice shortcut that we can use when we have a leading coefficient of 1. So again, this is only when we have a leading coefficient of 1. Okay, very important here. If we have a leading coefficient of 1, we're going to start off the same way we did when we were doing our factoring by grouping. We build a bridge. Again, that's just a phrase to remind us, multiply the first coefficient by the last coefficient. Okay, then we're going to find two numbers that multiply to the bridge, but add to the middle coefficient, just like we did when we were factoring by grouping. But here's the difference. If I have that leading coefficient of 1, once I build that bridge and I come up with those two numbers, instead of splitting up the middle term and then during factoring by grouping, I'm just going to take those two values that I come up with and I'm going to use them as the constant terms of my two binomials. I'm going to go right to the factored form of this thing, write my two binomials, and use those two values as the constant terms. And you'll see why here in a moment. We'll do this one the old-fashioned way here, and then we'll examine the shortcut. Okay. So for this one, again, I build a bridge, and keep in mind there's a 1 in front of this x squared here, so I've got a leading coefficient of 1, which means I'm going to be able to use my shortcut. I build a bridge, that's a negative 12. Two numbers that multiply to a negative 12 but add to a positive 4 are going to be a positive 6 and a negative 2. All right? And when we looked at this initially, we learned to do this. We split up this middle term into a positive 6x and a minus 2x. And then everything else tagged along for the ride. And I went ahead and did my factoring by grouping. Out of the first group, I can factor out an x, which leaves me with an x plus 6. Out of the second group, I can factor out a negative 2, which leaves me with an x plus 6. And now I can see the common polynomial of x plus 6. When I take that away, it leaves me with an x minus 2. But now look a little bit more closely at this polynomial, and we see an x plus 6 and an x minus 2. But look back at these values that I came up with. It was a positive 6 and a negative 2. And here I have a positive 6 and a negative 2. So what this is telling me, this shortcut is saying, hey, I can eliminate these steps that are in the middle, okay? And just say, I build a bridge, come up with the negative 12, the numbers are the positive 6 and the negative 2, so I can go right to saying x plus 6 and x minus 2. I use those two values as the constant terms to my binomials instead of splitting up the middle term. When we have a leading coefficient of 1, we are allowed to do that shortcut, okay? And we don't have to do the factoring by grouping. We can go right to that final answer. And that's it, okay? The same thing with the next one. Again, I'll do this one the old-fashioned way, and then we'll look at it in terms of the shortcut, and then the next two we'll just use the shortcut for, okay? So again, I've got a leading coefficient of 1 here. I build a bridge. Two numbers that multiply, build a bridge that gives me a 20. Two numbers that multiply to the 20 but add to the negative 9 are negative 4 and negative 5. So thinking about it in terms of my shortcut, my final answer should be an x minus 4 and an x minus 5. We can go right to the binomial and use those two values as the constant terms. But just to check it, I would split up this middle term into the negative 4x and the minus 5x. Everything else tags along for the ride. And now I do my factoring by grouping. Out of the first group, I can factor out an x, leaves me with an x minus 4. Out of the second group, I can factor out the negative 5, which leaves me with an x minus 4. And now I have in parentheses, the x minus 4 is one of my factors, and then the x minus 5 is my other. Okay, so you can see that I still come up with the same two binomials, whether I build the bridge, split up the middle term and factor by grouping, or whether I use that shortcut. So for this one, we can cut out all of these steps in the middle and go right to the answer. But that's only, again, that's only when I have that leading coefficient of 1. Okay, and that's it. If I look at the next one, this time, we'll just go right to this shortcut. We'll use it, see how it feels. Again, I have a leading coefficient of 1, which is a good sign. I can use my shortcut, so I build a bridge. It's a negative 100. Two numbers that multiply to a negative 100, but add to a negative 15 are going to be a negative 20 and a positive 5. They multiply negative 100. They add to negative 15. So that means I can go right to my binomial. I'm going to have one that's an x minus 20, and the other is going to be an x plus 5 because it's a positive 5. And that's it. Okay? I have a leading coefficient of 1, so I can use that shortcut. All right? The next one, I've got a leading coefficient of 1. I build a bridge. Two numbers that multiply to a positive 77, but add to a positive 18 are going to be a positive 11 and a positive 7. So again, multiply to a positive 77, add to a positive 18. Since I have that leading coefficient of 1, I can go right to the factors. It's going to be an x plus 11 because it was a positive 11, and an x plus 7 because it was a positive 7. And that's it. This thing is completely factored, and I was able to cut out a couple steps. All right? Taking a look at these last two, if I look at this first one that has the 3x squared, this one does not have a leading coefficient of 1. And I could build a bridge the way this is and split up the middle term and factor by grouping, and that would be fine. However, when I factored it, I'm going to find that one of my factors still has a greatest common factor in it because all of these still have a greatest common factor. They're all divisible by 3. And here's why we always want to look for the greatest common factor first. Look at how much easier this problem is going to be. If I factor out the 3 first, that leaves me with an x squared plus 7x plus 12. And now if I look at the trinomial that's in my parentheses, it's got a leading coefficient of 1. So when I build my bridge, that's a positive 12. Two numbers that multiply to a positive 12 but add to a positive 7 are a positive 4 and a positive 3. But the advantage here now, that trinomial has a leading coefficient of 1. Since it has a leading coefficient of 1, I can use my shortcut, which means I can go right to the x plus 4 because I had a positive 4, and the x plus 3 because I had a positive 3. And then this guy right here just tags along for the ride. So I had a greatest common factor of 3, and then the trinomial that was left factored into an x plus 4 and an x plus 3. So I saved myself a lot of work by factoring out the greatest common factor first. Okay? Same thing with the next one. These all have a greatest common factor of 2 in them. So I factor out the 2 first. It's going to save me a lot of work here. It gives me an x squared minus 5x minus 24. And now I've got a trinomial with a leading coefficient of 1. I build a bridge. Two numbers that multiply to a negative 24, but add to a negative 5. It's going to be a negative 8 and a positive 3. I can use my shortcut here now that I have that leading coefficient of 1 to give me an x minus 8 and an x plus 3 with, of course, that 2 tagging along on the outside. And that's it. This thing is factored completely with far less work than I would have had to use had I split up the middle term and done factoring by grouping. All right? So again, when we have a leading coefficient of 1, we start off the same way, but instead of using those two terms to split up the middle coefficient, I just use them to go to my two binomials. Okay?